We're going to solve these in radians over this domain. So we're solving an equation, and what's different about this equation, equation A, is it has two different trig functions. We've seen this a little bit before, like on your quiz review, and you're going to have a question like this on your quiz this afternoon. You had one of those that had sine squared and cos. And you had to use the identity that sine squared plus cos squared equals 1 to substitute it in. Because one of the goals for solving an equation is if you could write that equation with only one trig function, then you're going to be able to solve it. So for this first one, it has two trig functions, sine and cosecant. Is there any identity that you could use to substitute so that you only had one trig function? What could you do? You could change the cosecant x to 1 over sine x. Now, the biggest thing you're going to have to ask yourself at this point is if you have 2 cosecant of x, is that 1 over 2 sine x, or is that 2 over sine x? What happens to the 2? Does it move down to the bottom with the sign, or does it stay at the top? Well, the only thing we know is that cosecant is 1 over sine. So if I just keep the 2 out in front and I change the cosecant to 1 over sine, now we have to ask ourselves, what does that 2 in front do? Does it multiply the 1? Does it multiply the sine? Or does it actually multiply both of them? Okay? Well, go back to your fraction multiplying. If I'm multiplying fractions, 2 is actually 2 over 1. And so if I'm multiplying fractions, what is it going to be in the end? This one. Okay? Again, I point these things out because this is a very typical mistake that we run into. That when we're changing the 2 cosecant x to sine, what do? And sometimes that 2 gets moved down to the bottom, or you're multiplying and the 2 goes through to both of them. So we want to be reminded of those things so when we actually substitute it in, we substitute it in correctly. Of course, if I don't show you this and just show you the right answer, you'll like nod your head and think everything's good, and then you'll still make the mistake you were going to make prior. So now that we've done this, this is connected to something you did in grade 11. You solved equations like this. You solved equations that were 2x equals 3 plus 2 over x before. What did you do when you had that x on the bottom? Because that's a problem right now, solving this equation because we have an x in the denominator. Okay, what's that? Yeah, we did something to this. Since it was a problem, we did something to get rid of that. What's the opposite of divided by x? Multiply by x. So in this case, we could multiply this whole side by sine x, and we can multiply this whole side by sine x. And when you multiply both sides by sine x, what happens? Well, this becomes 2 sine squared, and when you multiply the right-hand side by sine x, it would get distributed. Each term would get multiplied, so you would end up with 3 sine x, and then nicely here it cancels out, and you just get plus 2. Now what kind of question is this? It's a quadratic. How do we solve quadratic equations? We have to factor, so we're going to make one side equal to 0. We're going to check if this factors nicely. If it did factor nicely, the only way to get 2 sine squared would be 2 sine x and sine x. The only way to get 2 is 2 and 1, but it's going to make a difference whether you put the 2 first and the 1 second, or the 1 first and the 2 second because of how the outside and the inside will work. One thing you might do is just do one at random. Okay, what would you like to put first, 1 or 2? Random, you just have to say 1. Or if you know what it is, what would you like to put first? You'd like to put the 2 first and the 1 second. So now we're going to check what's my outside, what's my inside. My outside is 2 sine x. My inside is 2 sine x. Can I ever add or subtract my outside and inside to make 3 with 2 plus 2? No. So sometimes we try something, when we check, we find out it doesn't work. So then we have to say, well, maybe it wasn't 2 and 1. Maybe it was 1 and 2. Now what's my outside? 4 sine x. What's my inside? 1 sine x. Does 4 and 1 ever add or subtract to make 3? Yes. If I want to make a negative 3, I would need to make my 4 negative, my 1 positive. Yes?
You also expand it and find within the 3 sine x, like the area. So you have 4 and 1. Find something that.
Yes, you could use the grouping method.
Yeah.
But for most of these, we're going to, the grouping method, what I find is that it takes longer because you have more to write. And often students make notation errors while they're doing it. So it's fine to use, but at this point, I'd like you just directly to be able to go to factoring. So now we get sine x equals negative 1/2 and sine x equals 2. This is on our unit circle. What family does sine equal to 1/2? Pi over 6 family, and it would be in quadrants 3 and 4. When is sine x equal to 2? Never. Even though that's not on our unit circle, because it's bigger than 1, you'd have to have the opposite side over the hypotenuse be equal to 2. That's never going to happen. So we can say non-possible. And this would be a question that would be on a non-calculator part of our exam. After we solve, okay, at this moment, without looking down at your book, can you tell me exactly, with all the right equal signs and everything, what the domain in this question was to begin with? Yeah, you look down. That's cheating. No, probably not, right? At this point, we're into the question, we're solving it, we've probably forgotten what the original domain was. So one thing that I've said before is when you're done a question, always go back and check. What was the domain? Was it all real numbers? Oh, and this one, it was between 0 and 2 pi. 2 pi wasn't included, but that doesn't affect our answers. Questions? For part B, sine x equals cos x. This one's harder because sine x and cos x, again, we've got an equation that the functions are not the same. And the temptation is to use this for substitution. Okay? The temptation is to do this. If sine squared plus cos squared is equal to 1, is sine x plus cos x equal 1? No. But you're going to be tempted to try to use that. So the only time you can use sine squared plus cos squared equals 1 to substitute in is if you have sine squared or cos squared, like we did on the quiz review that I gave you. Okay? But in this one, we can't just change cos x to 1 minus sine x. I mean, this is really obvious if you look at numbers. We know that 3 squared plus 4 squared is equal to 5 squared. Is 3 plus 4 equal to 5? No. Yeah. Just double checking.
Maybe in an alternate universe.
Maybe in an alternate universe. Right. I love those alternate universes where the best mark is to get an F and you feel good. Anyways. Did he? Sine x equals cos x. So there's two ways we can go about solving this question. Maybe you think about your unit circle. Is sine x ever equal to cos x? Is your x coordinate ever the same as your y coordinate?
Yes.
When? Pi over 4. Anywhere else? 3 pi over 4, one's positive, one's negative. 5 pi over 4, they're both negative. So method 1 is just knowing our unit circle and being able to say, I know when my x coordinate's equal to my y coordinate. Method 2, if I take this equation and divide both sides by cos, can you see that I would get this equation? Why is this helpful? Because sine over cos is 10. And then ask yourselves, on our unit circle, when is tan equal to 1? Pi over 4 and 5 pi over 4. So method 2 there was a way that we could change our value to be a single trig function. So in these algebraic questions, changing things to a single trig function can be a way to help us solve them. Okay, question number 10. I'm going to give you a few moments right now to work on that.